All right, welcome everybody to Files Day. Wait, it's the same day as Vectors Day. It is. Files means reading and writing to a file on disk. Pretty much every useful program in existence, not all of them, but most of them, will either read from the hard drive or write to the hard drive, right? So for example, right now I'm streaming using OBS. Let's create a Hall of Mirrors effect here. It's recording this right now, and it's writing all of this amazing video to the hard drive right now. It's writing to a file, okay? And we can do this very easily in C++. Reading and writing to a file in C++ is as easy as reading and writing to the keyboard and to the screen. All you have to do is tell it which file do you want to read from, which file do you want to write to, okay? So I'm going to move main.cc to old main.cc. And we're going to do files. So in order to get files working, you need fstream. There we go. And so let's say that you wanted to read two numbers from a file, add them together, and output the result. Now, if you're going to do this with a keyboard, you can do something like this. You do integer x equals 0, equals 0, always initialize variables, read an x and y, and then cout x plus y. Okay. If we compile it and run in, we type in 4 plus 5, we get 9. Cool. Now, if we wanted to read these two numbers from a file, let me make a file real fast. Temp.text. If I put a 4 and a 5 in the text file, this is a text file I just edited, temp.text. If I want to read the numbers from there instead of from the keyboard, I do this. I'm going to make an input file stream named ends, and I'm going to read from temp.text. And so this is the learning point 1, how to open a file for reading. So what does this mean? An input file stream means you are going to be opening the file for input, means you're going to be reading from it, not writing to it, you're going to be reading from it. This is the name of the variable, and that variable is going to replace cin. Okay? So instead of reading from cin is the keyboard, it's going to be replaced with ends. Otherwise, it's the exact same code as we had before. You see that? The only thing I had to do was tell C++ which file I'm going to be opening. It's this one right here, whatever is within double quotes, temp.text. It's in the local directory, by the way. Whatever file name I give it there, that is the file it's going to open. And then we can read from the file just like we read from cin, from the standard input. So it's going to read the 4 and the 5 from the file, and then it's going to print out the sum. And you can see that we got 9, same as before. Except now I don't have to type 4 and 5 every time. It's hard-coded, all right? If I want to change the numbers that are input, if I want to make this 40, then I don't have to recompile the program. You see that? I didn't have to recompile everything. I just changed the text file. And so this is really useful if you're making games. Sometimes it can take a really long time to recompile your code every time you change something. So you might be doing something like changing like gun damage and things like that. And it's a pain to have to recompile it and rerun it every time. So a lot of times what people will do is they will put the stats for the guns into like text files. And then they just hit a button and reload all the data and then shoot things. Like, that doesn't sound quite right. They edit the text file again, reload it, et cetera, et cetera. So that's it. That's all it takes to read from a file. Okay. And the neat thing is I can edit the file and my program will work differently every time without me needing to recompile the code every time. It's just going to read 2 minutes. If I wanted to use the read library for this, I could do it like this. And x equals read from ends, and y equals read from ends. And this is going to read 2 integers from this file, temp.text. And then it's going to add them together and print it out. So read library is the superior way, of course, of doing input in C++. But it's only on our server, or if you install it from the GitHub repo. It's not standard C++, even though it's better than the standard. Okay, and so read, and you pass in this variable name here. So that variable name is the file that it's going to read from, and it pulls out an integer from it. Now, if you want to do an output file stream, you just change the I to an O, And we will call this outs. Kind of like how my vectors are always called vec. My input file is always called ins. My output file is always called outs. It's just a terminology. It's just this convention I use. You don't have to call it ins. You do not have to call it outs. You can call this in file and out file if you want. It's just if I've got no better variable name, ins and outs it is. Got to know your ins and outs. Okay, so this is going to read 2 integers from temp.text, but rather than outputting the result to the screen, I'm going to write the results to out file. And that's it. That's all it takes to write to a file. So to read from a file, you can just replace cin with ins or in file. And to write to a file, you can just replace cout with out file or outs or whatever you call the variable name here. That's it. That's all it takes. And so now it's going to be reading from one file and writing to another, so nothing will appear on the screen. But if we were to open up, what do we call it, temp2.text, then you can see the output is in fact here in the file. That's it. That's all you really need to know. There is one warning. There is a sharp edge here. It will truncate, which means it will erase your file. Let's put it that way. So if I run this program again, it erases it every time and then puts 90 in. Okay, so there's not 90, 90, 90, 90, 90. You can open the file in append mode, but by default, it will truncate your file to 0 bytes, which means it's going to erase it. So do not do this. I've had students do every semester. Let's open main.cc for writing. They compile their code and they run it and it works. Whatever they wrote to main.cc is there. And then they're like, oh, okay, let me compile my code again. And they're like, oh, wait, my code's gone. Can you get it back from me, professor? So do not write to main.cc. That is a no-no. It will erase it. It will get rid of it. So don't do that. Learning point number 1, point number 2, how to open a file for reading, how to open a file for writing. There you go. That's it. That's files. Oh, one last thing. Learning point number 3. How do you tell when the file's done? How do you read integers? Let's say we're going to read into a vector and then add up the vector, kind of like what we were doing earlier. How do we know when we're done? Might as well leave this in here. Learning point 3. How do we know when we're done reading from a file? Infinite loop. So let me open up temp.text. And let me put YY60p. We're just going to put a ton of numbers in there. You know, maybe change some a little bit. I don't know. Okay. So we're going to read them all up and add them all together. Okay. So how do we know when we're done? How do we know when we hit the end? Well, what happens is this. So if you try your reading, or are these integers? Okay. So integer x equals 0. So if you try reading in an integer, and do you remember how we would do this if not cin? You know, if an error occurred? It's exactly the same thing, except again, in file replaces cin. Okay? So rather than reading from the keyboard, we're reading from in file. And instead of saying if not cin to see if an error occurred, we say if not in file. Okay? And that means an error occurred. Either a squirrel into the int, or we hit the end of file. If you want to test specifically for the end of file, you can do this. You could say if infile.eof, like that. If we hit the end of file, break. And so that's useful. You don't hit the end of file until you try reading from the file and there's nothing there. So let's say you read the very last number, you check to see are you at the end? The answer is no. An error occurs like this, or the end of file occurs only after you try getting the next number out and it fails. So every time you do a read from a file like this, the first thing you should do is check to see, did I hit the end of the file? Because you're gonna hit it eventually, right? And that's not an error, right? Like especially if you had something like this where you were like dying, right? Like if there was like a squirrel in the text file, die. Nah, you don't want to. It's normal. Like at some point you're gonna hit the bottom of the file, so quit. You know. So this is just exit. So this is a way of checking to see specifically did I hit the end of the file. If you don't care about the specifics, then this will also check for the end of the file, or for an error occurring, and you don't know which one is which. So just depends on what you want. Those are two different ways to check for the end of file. So basically, you read from the file, you see, did I run off the end? If so, quit. If not, then we'll add it to our vector. Okay, so we got our vector of integers here named vec, size 0. And we're going to read in an integer, and then we're going to say vector dot push back x. So if everything's good, we put it into the end of the vector. Then at the end of the day, we're going to do a accumulate, cout, accumulate, vector dot begin, vector dot end, 0. Why do you do that to me? 0, like that. That actually wasn't my typing. That was Commander of Completion deciding it was going to very helpfully fill in some things for me. So that's the sum of all the things in there. And we can also say for every integer in the vector, cout the integer. And so there's all the 40s and 50s and 41s. We just read the entire file. It's all in the vector. And then if we add them all up, the sum is 5507. And that is very, very common. This is an extremely common pattern that we use in computer science. Having an empty vector, infinite loop, read from a file. If we hit the end of the file, we're done with the loop. Break out, which jumps down here and prints it out. If an error occurred, if there's a squirrel or a floating point over something in the file, we die. This could be replaced with a die function. If everything checks out, add it to the end of the vector, move on. And so after this loop finishes, this vector contains all of the data in that text file. Yep. And then we can print out the vector like that. We can sum up everything in the vector like that. This is bread and butter computer science, right? Opening up a file, summing it up, whatever, loading map data in a video game, whatever. So what I'd like for you guys to do is I would like for you to, there's a user share dict words. So this file here contains the entire English language, okay? So we got zoning and zonked and zoological and zucchini. So what I'd like for you guys to do for the remainder of lab time, and once you finish it, you can quit. I would like for you can bail out lab time. Find me the largest word in the English language. Okay. And again, that text file is here. And this is a very useful file to know because you can use this to do games like Hangman, right? You open up the entire English dictionary and then you just randomly pick a word out of it. You can use it for word searches, crosswords, to see if Scrabble, like the user types in a word, you check to see if it's a Scrabble word. Extremely useful, spell checking, like it's extremely useful. So what you're going to do is you are going to open up user share dict words. You don't need the out file anymore. Yep. And your lab time is open up the whole thing, read the whole thing, and find me the largest word in English. Once you guys do that, print the word onto chat, and then you can leave. Okay. Begin. Okay, let's find the longest word in the English dictionary. boom, boom, boom. We don't need a vector for that. Don't need a vector, don't need a vector. We will need to keep track of the longest word that we've seen. Don't need you. We'll do a little temp here. S. Okay. Done. Okay. So if the word that we've just read in, if s.size is greater than the length of the maximum size we've seen, then the maximum length word that we've seen is equal to s. That's it. Okay, cout max. So we compile it and run it. 40, what 40? I don't think 40 is the longest word. Oh, because I'm not reading from the dictionary. How about we read from the dictionary instead? Okay. It's like 40. We're doing integers now? What is this? Okay, let's compile that, run it, and there we go. The longest word in the English dictionary. This computer science 40 is really fun and full of life and joy. So everybody who got that, you can leave now. Everybody else, I don't know. There's a lot of people like doing some like Navy SEAL copy paste. I don't know. A lot of anger from the from Garza and Olson. I don't know what's happening here. Anyhow, so that's the longest word in the English language, and I don't know why all you guys were sending the Navy SEAL copy paste at me, but no, I edited the dictionary right before I ran here. So that's how you do it. One last glance at this. This is going to be this opens the dictionary file. So some people were putting max here, and that's gonna reset max to be blank every time, because max dies at the end of the curly brace, right? So it's going to throw away max every time the loop iterates. So what you have to do is keep max outside of it. And then every time you read a string, you just check to see if its size is bigger than max's size. And if so, that's the new victor. That's the new longest word. And we just save it. And then after we've gone through the whole dictionary, we print the longest word. Done. That is it for today, guys. Hope you learned a little bit about reading files in and out. See you guys on Friday. Peace.